Hello my dear students, welcome back to Learn Physics. In today's video also we are continuing with the projectile motion. So last class we learned how to solve the projectile motion problems. In that we learned initially if it is moving in the upward direction or downward direction or in the horizontal direction and then moving towards the downward direction in any way. Anyway, what we should do is we should convert that into components and the respective component alone we should check, because if it is a height they are asking, the distance covered if they are asking, we should consider the y component. And if the distance from the origin to the last point, if they ask like that, we should find out we should consider the x component. Okay, so last class also some of the solved answers we did and some introductory exercise also given in this DC Pandey sir's book. So as you all know, I am following as level 1 we are following DC Pandey sir's book, and so we will start with the numerical session, and if you require the theory portion you can just go through the description box. There I had given the full detailed theory of motion in a plane. About that whole chapter I had given a detailed theory. You can go through that if you require the theory portion. Now first question, two particles are projected from a tower horizontally in opposite directions with velocities 10 meter per second and 20 meter per second. So we are throwing two objects, one is 10 meter per second and the other is 20 meter per second horizontally but in opposite direction. So I am considering this 20 meter per second in the opposite direction. Find the time when their velocity vectors are mutually perpendicular. So if two vectors are mutually perpendicular, then we need to consider, so this is the velocity vector and this is also velocity vector. We need to find out the time when both are mutually perpendicular. So v1 dot v2 equals 0. If both the vectors are perpendicular, then that velocities will be equal to, dot product will be equal to 0. So here we can write it as 20 I dot. So final velocity in these two cases, how can we find out the final velocity? So after time we don't know, at what time will it be mutually perpendicular, that we don't know. So what should we do? V equals u plus at. So ux plus ax into t. Vx will be equal to, Vx is equal to, along the x-axis it is moving like that, and y-axis it will be the component along the y-axis when it is moving in projecting horizontally like this. So here y component also will be there. Then we need to consider the y component uy, ay, t. Okay, so here Vy will be equal to uy as 20 plus ay as 10, t we don't know, right? Then here this is V1I, same way V2y also we can find out. Uy is 10 plus 10 into t. Now we can take the dot product, 20 plus 10t, this is j cap plus dot 10 plus 10t j cap. J dot j is 1, therefore 200 plus 100 t square. So that is equal to 0. Therefore we will get it as 200 equals 100 t square. Thus t we will be getting it as root 2. Here negative sign, here we didn't consider the negative sign, because here positive means this one we need to consider as negative. Okay, clear? So at which point both are perpendicular, both the vectors are perpendicular. If a question comes like that, you should do the better option is go for the dot product. Okay, so here final velocity of the first vector dot final velocity of the second vector after t is equal to 0 at an interval of time t. Okay, so when it is moving like this, y-axis we can consider since the movement is in the downward direction. Initially it is horizontally projecting and after that it will move towards the x as well as y. We can divide that vector into the components. So that one we can consider it Vy, v equals u plus at. That formula we are applying and you are getting it as minus 20 plus 10t, that is along the left side, and towards the right side I am taking it as positive. So here it will come minus 200 equals 100 t square, t we are getting it as root 2. Clear? So the next question is, projectile motion is a three-dimensional motion. Is the statement true or false? Projectile motion is a two-dimensional motion because xy plane, it will be considered on a plane. So it's a two-dimensional motion. Projectile motion is uniformly accelerated motion. Yes, that also true only because acceleration we will always be considering it as acceleration due to gravity. It's a uniformly accelerated motion. Next question. A particle is projected from the ground with a velocity of 50 meter per second. So we are projecting a particle from the ground with a velocity of 50 meter per second. So initial velocity is 50 meter per second at 37 degree from the horizontal. So with the horizontal it is making an angle 37 degree. Find the velocity and displacement after 2 seconds. And sine 37 it is given as 3 by 5. Sine 37 equals 3 by 5. So how can we find out, as I said you in the previous videos and this question also I told you to find out the velocity. What should we do? It is moving in xy plane. I am considering that my object is moving in xy plane. So I can divide that into its components. So how can we convert this u into its component along x and y axis? When I am considering u, I can divide it as ux, that is u cos 37, and here it is uy as u sin 37. Okay, we have the value of sine 37 but we don't have the value of cos 37. We can use this trigonometrical equation sin square theta plus cos square theta equals 1. Therefore, cos 37 will be equal to root of 1 minus sine square 37. Okay, so here root of 1 minus 9 by 25, therefore 16 by 25, 4 by 5 we will get. Okay, therefore we will be getting the ux. Ux equals u as 50 into cos 37 as 4 by 5, that is 40 meter per second we will get along the x-axis, or we can write it as 40 I cap. And now we can consider uy. Uy equals u sin 37, already given it as 3 by 5. U value we know it as 50, therefore 30 meter per second. Now how can we find out velocity vector? Final velocity vector will be v equals u plus at. So along x-axis when I am considering. So here it's moving along upward direction. So both x and y-axis we need to consider. So vx will be equal to ux is 40 plus acceleration. Acceleration along x-axis is 0. Therefore, this is existing as 40 meter per second. And now we can move for Vy. Vy equals Uy. How much it is? Uy we got it as 30 plus acceleration. It's acting in the upward direction. Therefore, minus 10 into t is 2 seconds. It's asked for 2 seconds. Therefore, we will be getting it as 10 meter per second. So, what is V? V will be equal to 40 I cap plus 10 j cap. This will be the final velocity vector. Clear? Now, same way we can find out for the displacement. How we can find out? S is equal to ut plus half at square. Sx equals ux. Ux we got it as 40 into t is 2, half at square. A is 0, therefore we are getting displacement as 80 I cap. Now along y-axis, s is equal to uyt, 30 into t minus half into a is 10 into t square. So here we will be getting it as 60 minus 20, therefore 40 j cap. So SV we got it as 40i plus 10 j cap, and S we are getting it as 80i plus 40 j cap. Okay, clear? So here and all you should know only the direction. So along x-axis, while we are considering, no need to consider the acceleration, because acceleration is almost 0 along the horizontal direction. Only y-axis acceleration is acting. Earth acceleration won't be considering in the horizontal direction. It is only the vertical direction. So acceleration term we need to apply only for the y components. Okay, clear? Next question is, a particle is projected from the tower of a height 25 meter with velocity 20 root 2 meter per second at 45 degree. Find the time when the particle strikes the ground, the horizontal distance from the foot of the tower where it strikes, and also find the velocity at the time of collision. Okay, a particle is projected from a tower of height 25 meter. So height of the tower is 25 meter is with a velocity 20 root 2 meter per second at 45 degree. With a velocity 20 root 2 at an angle 45 degree. Okay, find the time when it strikes the ground. So time required to strikes the ground. We need to find out the time. Then horizontal distance from the foot of the tower when it strikes. So this horizontal distance we need to consider, and also find the velocity at the time of collision. Okay, V, final velocity also we require. Okay, how can we find out? Here also we need to consider the two components. So initial velocity given as 20 root 2, therefore ux will be equal to u cos 45. So 20 root 2 into 1 by root 2. 1 by root 2, that is equal to 20. We will get uy equals u sin 45. That also we will be getting the same value. Okay, 20 I cap and 20 j cap. Now we can move for the time. Total time. See, to find out, it is moving in the downward direction, right? When it is moving in the downward direction, we need to consider only the downward component, that is one y component alone we need to consider. So along when we are considering the y component, see here it is moving with a 25 meter distance, right? So this 25 meter S is along y axis will be equal to 25. Then we don't know the time we need to find out. Uy we know it as 20, acceleration we know it as 10. So S is equal to ut plus half at square we can apply. So here Sy distance along y axis will be S is equal to ut plus uyt plus half ayt square. What is Sy? 25 meters. It is downward direction, right? So it is, we can consider it as minus 25, that is equal to uy is 20t plus half into 10 into t square, right? So here we will get it as all can be divided by 5, therefore minus 5 equals 4t plus 4t plus t square. So t square plus 4t minus 5 equals 0. So we will be getting it as t minus 5 into t plus 1 equals 0. You will get t as 5 seconds. T minus 1 is not, we can't take the t as minus 1, therefore t equals 5 seconds. So here we got the value like that. Can you tell me how we will be finding out the r distance from the horizontal, this horizontal distance? How can we find out? We should consider only the x axis. So Sx equals uxt plus half a by t square. In that, this is not required. We need to take only Sx equals ux into t. See, ux we already got it as 20 into t is 5. Therefore, it will be equal to 100 meter. Okay, clear? So this is how we will be solving this equation. So I hope this kind of questions are thorough for you. Now we are moving to the small theory portion, that is time of light, range of projectile and maximum height that can be attained from a projectile. So next portion is time of flight, horizontal maximum height and horizontal distance that the projectile is attaining. So in those cases, the time of flight means total time that the projectile is at in the during the flight. Okay, during the flight, how long it will be taking. So that is t equals 2u sin theta by g. U is the initial velocity which we are giving. So initial velocity, and theta is the value which is it is making with the horizontal, and the other values you know. H is equal to u square sin square theta by g. H means maximum height. This is the maximum height. Okay, this is R is the horizontal range, that is from here till this, from the starting point till the same horizontal distance, how much it is reaching, that is horizontal range. So u square sin 2 theta by g. In this you should by heart this formula, and then here some other things which you need to remember is when we will be getting the maximum horizontal range. Maximum horizontal range we will be getting when sin 2 theta equals 1, when sin 2 theta is equal to 1. So in that case our maximum we can write it as it will be equal to u square by g. When that maximum value will be attaining, when sin theta equals 1, therefore we can write it as theta will be equal to 45 degrees. So if the projectile is moving at an angle 45 degree, the maximum range will be equal to u square by g. Okay, clear? So at this maximum range, this when we are considering the maximum height, that will be equal to 4h, 4 times the height obtained at that time. Okay, at 45 degree, what is the maximum height? So maximum sin 45 is equal to 1 by root 2. So while you are getting h maximum, when you are considering h maximum, that is when the range is equal to 45 degree. When range is maximum, then theta will be at what time, what will be the angle? So here u square sin square theta means sin square 45, it is 1 by root 2, 1 by 2. So 1 by 2 into 2g. So it will be 4 times the maximum height. Height when it is at 45 degree, our maximum will be equal to 4 times h. Okay, this one clear, children? So these are some of the terms which you need to by heart. All of you by heart these equation. 2u sin theta by g is maximum, total time required. H is the maximum height. R is the range, that is horizontal range. Okay, so relating to this, the numericals we will be doing it in the next class. So I hope today's video is useful for you, and if you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.